Alright, can people hear? Okay, so yeah, I don't have the webcam setup doesn't actually work, so I'll probably just have to write on paper and then like latex some stuff to yeah, like I'll probably write on paper and then latex some stuff and then that's probably how I'll have to do it. Um, so yeah, it's a bit suboptimal, but um, okay, I'll just start now then. Uh, Gonna just start the timer, I guess. 3, 2, 1, and alright, so we got some random limit question. Lim as x goes to infinity. It's just L'Hopital's, right? Yeah. So 1a is just lim 3x squared plus 2x minus 4 on 5x squared plus 8x minus 1 is equal to lim as x goes to infinity of 6x plus 2 on 10x plus 8, because L'Hopital's infinity over infinity, which is in turn equal to lim as x goes to infinity of just 6 on 10, because of, again, L'Hopital's. And infinity over infinity, which is equal to just 6 over 10. Alright, pro stuff. Evaluate the definite integral. This seems... This is like... Okay, first I'm going to sub. Because I swear this is like one of the trig ones, right? It's like... let me look up the formula sheet. Do they not have... Do they not have, Do they not have... That's kind of suboptimal, okay. So they don't have... Alright, but I swear it's like... Or if you just take like... If you just take like sine... It's like arcsine, right? Arcsine of x. What does arcsine of x arcsine of x, what does arcsine of x differentiate to? You get like x equals sine of y. Why is this not... Wait, was this in the formula sheet, by the way? Do they have inverse trig in the formula sheet this year? Because I'm on last year's formula sheet, but... I forgot how to do this. D over dx of sine y is just cos y. Cos y dy. Alright, so this just cos of arcsine of x. So that's the angle. Wait, there's just sub like u equals x squared or something silly. Alright, you get like integral from 0 to a of u divided by a to the 4 plus u squared d. Alright, integrals are kind of unfortunate. I'm just gonna skip this one for now. Oh, see, this is just like Vieta's formula, right? You get like, if you expand like x minus alpha, x minus beta, x minus gamma, x minus delta, you get x to the 4 minus alpha plus beta plus gamma plus delta x cubed plus alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta x squared plus. Oh wait, no, you need the a in the front, right? Yeah, okay. But that just still works. Plus a times, no, it has to be minus. So alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta x plus alpha beta gamma delta, because you just expand the quartic, right? So it should just work. This is Vieta's formula. And then so and you should just be done. Therefore a times alpha plus beta plus gamma plus delta is equal to b, implies alpha plus beta plus gamma plus delta is equal to negative b on a times alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta is equal to c, implies that alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta is equal to c on a. And also you get negative a alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta is equal to d, implies that. See, this is what I mean when I say Skull is just level 3 but 5 times more bashy. Alpha gamma delta plus beta gamma delta is equal to negative d on a, and a times alpha beta gamma delta is equal to e, implies that alpha beta gamma delta is equal to e on a. Right, per stuff. Now consider this equation. X to the 4 there are two roots whose sum is equal to the sum of the other two roots. Then find the exact value of p and exact value for the roots. Okay. Alright, let's call the roots a, b, c, d. Not writing those Greek letters again. B, C, D, and without loss of generality, assume a plus b is equal to c plus d. Alright, then you get that, you should just get that like a plus b plus c plus d is equal to 8, which implies that a plus b is equal to c plus d is equal to 4. Okay. Nah. So you get like Okay, so you should get something silly like um you should get like crap. Alright, I'm just gonna batch this. Let's go AB plus BC plus C no AB plus AC plus AD plus BC plus BD plus CD is equal to 19 presumably. Um and then we should just get that you should be able to factorize this probably. Um A times C plus D, cause C plus D is 4, right? So you get A times C plus D plus like B times C plus D plus AB plus CD is equal to 19. But C plus D, so basically you just get that like 4 times, you just get 32 plus AB plus CD is equal to 19. AB plus CD is equal to like negative 13? That seems wrong. Alright, now whatever. Should be fine. And then you want to find yeah, okay. And then you have that ABCD is equal to ABCD is just equal to 2 from the last equation. This doesn't seem right. You shouldn't be able to get. No, actually no, that's fine, that's fine. Okay, so if you just solve this as like right, okay, so you get AB plus 2ABCD plus CD. No. Wait, you take because you should just be able to solve like if you let x equals AB and then y equals CD, then it's just x plus y is equal to negative 13, and then xy is equal to 2, right? Oh, right. So you just let like x equals 2 on y, then you get 2 on y plus y is equal to negative 13, implies y squared plus 13y plus 2 is equal to 0. That does not seem to have nice solutions. 1, 13, 2. Solve. Yeah, that has horrible solutions. Okay. I wouldn't put it past NZQA to have like horrible solutions though. Okay, right, fine. So what if we do assume that this is correct? Then you should just get like alright, you say like y is equal to negative 13 minus root 161 on 2. That's one of the solutions to the quadratic. Then you get like, which is equal to like CD, right? And then you get C plus D is equal to 4. And then you just solve this in the same way. Right? D is actually you might not have to. You might not have to. You might just be wait, you go like D is equal to 4 minus C. Negative 13 minus root 161 on 2 is equal to C 4 minus C. Alright, you should just be able to solve this with like a alright, so if we take if we copy that negative 13 plus 1 root 161 on 2, alright? Or minus, it doesn't matter. Both of them, we have to use both of them anyway. then you get some like you get some horrible solutions. All right. I doubt this is what NZQA wants you to do, but I probably made some arithmetic error. Let's go back. Oh wait, it has fuck. It has to be 16. Yeah, okay. Yeah, because it's a plus b, right? It's a plus b times c plus d, so it's 4 times 4, not 4 times 4 plus 4 times 4. So it's 16, and then you get that, and then you should get nicer solutions. Yeah, I knew I made a mistake. This is kind of suboptimal. Okay, what do we get now? If we let x equals a, b, and y equals c, d again, and then you get x, y is equal to 2, x plus y is equal to 3. You get y is equal to 3 minus x. X times 3 minus x is equal to 2. Yeah, this looks a whole lot nicer. Right, you get that x is equal to 1 or 2. And then we log that x equals 1. Then y is equal to 2. Okay, this looks a whole lot nicer. Then you get a plus b is equal to 4 and ab is equal to 1. So you get a is equal to 4 minus b. 4 minus b times b is equal to 1. B squared minus 4b plus 1 equals 0. Does that even have... No, it has to have solutions, right? 1, negative 4, 1. Oh, you just straight up get 2 plus minus root 3. Okay, why not? B equals 2 plus minus root 3. By the way, I'm getting the calculator to solve these quadratics for me. I'm pretty sure you can do that in CA or scholarship exams. And then you get c plus d is equal to 4, cd is equal to 2, and then c squared minus 4c plus 2 is equal to 0. This does not look nice. And the c is equal to 2 plus root 2, and d is equal to 2 minus root 2. Okay. Okay, so now we have all 4 of the roots. Then you can just multiply them together. I'm fairly sure you should just be able to multiply them together. Right, yeah, okay. So if you take... let 2 plus root 3 is to be a. 2 minus root 3 to be b. 2 plus root 2 c 2 minus root 2 to d, and then you can just go like abc plus bcd plus cda plus dab, and then you get 12. Pro stuff. Wait, do you need the negative? Right, because yeah, it's negative. Okay, that's fine though. Not a big error. Alright, so p is negative 12, and exact values for the roots. And the roots are some permutation of 2 plus root 3, 2 minus root 3, 2 plus root 2, and 2 minus root 2. Alright, pro stuff. That's 17 minutes on question 1, but I still haven't done that that integration one though, so I'll have to come back to it later. If x to the 4 plus 1 on x to the 4 is equal to 7, find the exact value of x to the 8 plus 1 on x to the 8. Alright, so fairly sure you should just be... Wait, you literally just square, right? 2a, x to the 4 plus 1 on x to the 4 squared is equal to 49, but the left hand side is equal to x to the 8 plus 2 plus 1 on x to the 8, which is also equal to 49, thus x to the 8 is plus 1 on x to the 8 is equal to 47. QED. Alright, nice. Given f of x is equal to cos x 2 plus sine x on the domain 0 less than or equal to x less than or equal to 2 pi. Okay. Find the exact coordinates of the turning points of f of x. Alright, let's just graph it on the calculator to see how it actually looks like before you actually start trying to solve the question. 2 plus sine x. V window should be trig. Okay, so it looks like sort of there doesn't appear to be any point of inflection. Actually, no, there is one point of inflection, I think. And then there's a maximum. When's root 2? Yeah, so there seems to be a maximum just before 2 pi and a minimum like just after. Oh, scroll the question paper down, sure. There's the minimum just after. Yeah, there's a minimum just after pi. There's a inflection like around half pi. And then there's a maximum just before 2 pi. Alright, so if we just differentiate this, you use like, what is it? Like, quotient rule. Quotient rule, yes. Just use quotient rule and then it should just work. Quotient rule. If on g prime is equal to g times f prime, so that would be negative sine x times 2 plus sine x. Minus f times g prime, cos x. 2 plus sine x. Wait. No. 2 goes, so it just cos x. Okay. Which is supposedly equal to 0. At the stationary points. At the turning points. Okay, so we just set that equal to 0. You can always cancel the bottom because 2 plus sine x is always positive. Alright. So you get negative sine squared x plus minus 2 sine x minus cos squared x equals 0. And you use Pythagorean identity. You just get sine x is equal to a half. Negative a half. That makes no sense. Why would sine x be negative a half at the turning points? Okay. Wait, actually, if you graph it, it looks about right. Like, the turning points sort of align with when sine x is equal to negative 2x. Sorry, negative half. But then there's that weird. Maybe that isn't a point of inflection. Maybe that's just like a normal point as well. Okay. So, wait, so part 2 is just like a scam, right? Because there's no points of inflection. Okay. I don't like this. Alright, so arcsine negative a half is negative pi on 6. So the solutions in 0 to pi are like they would be like 7 pi on 6. 7 pi on 6, and there would be 11 pi on 6, I think. Let's check that with the calculator. Sine of 7 pi on 6 is, yes, it's negative half. Sine 11 pi on 6 is also negative. Alright, that's the pro stuff, that works. Nice. Okay. So you just second derivative test, I think. This seems bad. Wait, actually no, it can't be that bad, right? Cause if prime of x is literally just negative 2 sine x minus 1 on 2 plus sine x squared, right? So if we just differentiate that, you should get like, what do you get? You get apply quotient rule again, I suppose. 2 plus sine x to the 4th power. Derivative of sine is cos. Oh wait, actually no, wait, no. There are inflection points, cause graph changes convexity, but it might not. Because just because it's an inflection point doesn't mean it's also the derivative has to be 0. So yeah, okay. So there might still be inflection points. Just look at the graph. So if g prime is 2 sine plus 1, you just like alright, now you just plug in if prime of 7 pi on 6 to the wait, first you need to find, wait, actually no, you plug in if prime of 7 pi on 6 to the thing, and what do you get? You get let me just, this is gonna take a long time to write out on my calculator, but alright, fraction 2 plus sine x squared negative 2 cos x plus 2 sine x plus 1 2 plus sine x cos x. I'm pretty sure that's the correct second derivative, but I might be wrong. And it's 4 root 3 on 9 at 7 pi on 6. So 7 pi on 6 is a maximum. No, it's a minimum. Wait. Far out. Seven pi on 6 is a minimum, yeah. Okay. Now if prime prime of 11 pi on 6 on the other hand is actually equal to negative for root 3 on 9. Interesting. So 11 pi on 6 is a minimum. And then you can just go like, it asks for the coordinates, right? So you actually have to plug them back into the function. Now if of 7 pi on 6 is actually, if of 7 pi on 6, because if it's just cos x over 2 plus sine x, right? So that's not that hard to evaluate. If of 7 pi on 6 is negative root 3 on 3, and if of 11 pi on 6 is just root 3 on 3. That's weird. That's like, why does it evaluate like that? Okay, whatever. So the minimum is at 7 pi on 6, comma negative root 3 on 3, and then the maximum is at 11 pi on 6, comma root 3 on 3. Alright. That's good, that's good. Okay. So 2b2. Discuss the concavity of... Okay, so this is the part where you need the second derivative. So if prime prime of x is equal to... So when is... Actually, you only need like, when is if prime prime of x positive? Right? Ow. Alright, if prime prime of x is equal to... Okay, what we'll do is this. Because if prime prime is continuous, then since at a point of inflection, if prime prime goes from being negative to positive, if prime prime just changes sign, it must pass through 0. Alright, pro stuff. Then we just need to set, since 2 plus sine of x to the 4 is always positive, we can cancel the denominator. Nice, nice. Okay, okay. So we just have we should just have like 2 plus sine x squared negative 2 cos x plus 1 plus 2 sine x 2 plus sine x and cos x is equal to 0. And then you can cancel the cos x, and you can also cancel the 2. And you can also cancel one of the 2 plus sine x's. And then you're actually left with like something pretty trivial. You get 1 plus 2 sine x minus 2 minus sine x is equal to 0. Sine x is equal to 1. X is equal to pi on 2 or 3 pi on 2. That seems way too nice for an NZQA question. But whatever, yeah, why not? So actually, we know that the regions 0 pi on 2 pi on 2 3 pi and 3 pi on 2 to 2 pi have the same concavity among themselves. So it suffices to check. The second derivative at 0, the second derivative at pi, and the second derivative at 2 pi. Okay, so the second derivative at 0, if we just plug it in, it should just be, let's see. The second derivative at 0 is negative a half. The second derivative at pi is positive a half. And the second derivative at 2 pi, it should just be negative a half again, because it's the same, but I'll just check it. Yep, it's negative a half. So the region 0 pi on 2 and 3 pi on 2 to 2 pi has negative concavity. Negative second derivative. So it is, I cannot remember the actual terms for this, but I think it's like it goes down, right? So I'm just gonna call it concave down. I can't remember the actual term for it. Derivative. So it's concave down, and the region from pi on 2 to 3 pi on 2 has positive second derivative. So it's concave up. So the points of we should probably calculate f of pi on 2. We need to calculate f of pi on 2. F of pi on 2 would be like pi on 2. Is it actually 0? Okay. Sure, why not? f of 3 pi on 2 is also 0. Wait, I know the second derivative is 0, but why is the function just straight up also 0? Okay, fine, I won't question it. That's what the calculator says, so. So the points of inflection are pi on 2, 0, and also 3 pi on 2, 0. Pro stuff. Alright, and it just says discuss the concavity of f of x giving any points of inflection in exact form. So I think I've done that. Right, nice. In the accompanying diagram, ABCD is a cyclic. Ooh, this is geometry. See, this is pro stuff. 2C1. Wait, this is literally just Thales, right? Because you get, okay, you got the circle. A, B, C, D. Right. Is it implied that... And this is just theta, this is A, this is A, this is B, this is B. Okay. So... okay. So I think what it is that surely you could just say, because of symmetry, AC is the diameter of the circle. I'm just gonna say that. Because it has to be, right? Because it's the entire diagram is symmetric around AC. By Thales' theorem, or angle by semicircle arc theorem. I think that's what NZQA calls it. Semicircle arc theorem. Semicircle or diameter arc theorem. I can't remember what NZQA calls it, but whatever. It's the same thing. We get angle ABC is equal to angle ADC is equal to 90 degrees. Yay! And so what you get is that angle BAC is just theta on 2, right? But A on B is actually tan theta. No, it's tan theta on 2. Okay. Yeah, so A on B is tan. No, wait, no, that's B on A. B on A is tan theta on 2. B on A is tan theta on 2. So A on B is 1 on tan theta on 2. Alright. And then does NZQA give half angle formulas? Because I can't remember them. Wait, surely, okay. Surely they must at least give double angle formulas, right? Wait, no, we don't need the double angle formulas, right? You can just... Yeah, alright, this is big brain, or maybe not. No, it is. Alright, so because of this is just because of definition of tan. Because by symmetry. Because of the definition of tan. Alright, now we just sub it in, right? RHS is equal to 1 plus cos theta on sine theta, which is in turn equal to 1 plus sine theta. No, because you just use the double angle formula for cos, right? So you get 1 plus, because cos of 2a is equal to cos squared theta on 2 minus sine squared theta on 2. Alright. Is equal to that minus, no, it's just that, and it's over 2 sine theta on 2 cos theta on 2. Right, now we're getting somewhere. And then what you just need to do is you apply like, cause 1 on tan is cos and sine, right? So you just want to get rid of the sine by Pythagorean identity. Cos squared theta on 2 plus sine squared theta on 2 is equal to 1. Pythagorean, I'm spelling it right, identity. Which is just equal to 2 cos squared theta on 2 on 2 sine theta on 2 cos theta on 2, which is in turn just equal to cos theta on 2 on sine theta on 2, which is equal to 1 on tan theta on 2, which is equal to the left hand side, which is equal to A on B. QED. And calculate the magnitude of theta if, okay, so it's basically just saying B on A is equal to 1 on root 3 implies tan of theta on 2 is equal to 1 on root 3. Theta on 2 is equal to arctan of 1 on root 3, which is just equal to like, it's something silly, which is equal to pi on 6. Alright, pi on 6, which implies that theta is equal to pi on 3. Nice. And that's Q2 done. And we didn't skip any questions this time, so cool. Q3. Why? What is this? Given that f of x is equal to that weird thing. Oh, I see. Okay. Okay. Okay, I get it now. Right. Right, okay. Yep, I think I see what's going on. So basically, the fact that the second derivative exists means that the left hand limits first it has to be continuous, right? Which implies that, of course, b is equal to like e to the 0 plus sine of 0, which is equal to 1. So b is equal to 1, alright? And also, limit as x goes to 0 minus of if double prime of x has to also equal to limit of x goes to 0 plus of if double prime of x, which means that two x plus a, no, it's the second derivative. Wait. No, you just take the first derivative. Because if you take the second derivative, then you get a to disappear as well, which you don't want. So you just take the first derivative. 2x plus a is equal to e to the x plus cos of x, which means a is equal to e to the 0 plus cos of 0 is equal to 2. So a is equal to 2 and b is equal to 1. Seems fine. Alright. Smooth curve. You know, NZQA doesn't actually define like smooth curve or anything. They're like, kind of sus. Smooth curve over the interval -2, 2 that passes through the point. Wait, why is this a circle? This is literally just a semicircle with radius with radius 2. Why is literally just a semicircle with radius 2? Am I allowed to say that? Because I mean it is. Why is literally just a semicircle with radius 2? Because okay, it's smooth curve. Semicircle is a smooth curve. And then the tangent to the curve passes through the center of the circle, right? The tangent, the normal, the the um the normal of the normal to a circle is like it's like the perpendicular to the tangent, right? And then the perpendicular to the tangent always passes through the center of the circle. This is like level 1 stuff. So, I mean, okay, y is a circle, so you can prove that you can prove that x squared plus y squared is constant or something. Okay. Let's just try solving the dE, I guess. How do you set up a dE for this thing? So if you have a point, if we have a point, f of x, no, x naught, y naught, then dy on dx at x naught, y naught. Because it's the negative of. Because it's just a negative, right? It's a negative of the slope of the line from 0, 0 to x naught, y naught is the slope of the line is y naught on x naught. Cool. So dy dx is normal. Dy dx at x equals x naught is negative x naught on y naught. Wait, yeah, this is literally just the this is just literally the dE for the circle. Okay, so this holds for all x naught and y naught, which implies that dy on dx is equal to negative x on y, and this is just a separable dE. Y dy is equal to x dx, negative x dx, I must add. Y dy is equal to negative x dx. You integrate both sides. Integral of y dy is equal to integral of negative x dx, and then you get y squared is equal to negative x squared plus c. X squared plus y squared is equal to c, and the curve passes through what does it pass through? Root 2, negative root 2, which implies that x squared plus y squared is c is equal to root 2 squared plus negative root 2 squared, which is equal to 4. Right, so x squared plus y squared is equal to 4. Nice. And y is equal to negative root 4 minus x squared. It's the negative because the curve is smooth. So y can't alternate, and y is negative at x equals root 2. So the final answer is y is equal to negative square root of 4 minus x squared. Alright. The rates of increase of the length and width. Alright. This is just okay, so the length and width. Why do they say length and width? Length is equal to 12 cm and width is equal to 9 cm. Alright. So let the length of the diagonal be d. Diagonal be d. Okay, so d is equal to the square root of w squared plus l squared. And then you should just get that, you just differentiate this with respect to time. dd on dt is equal to, alright, and now I find out why d is probably a bad variable to use, but whatever. Wait, how do you do this? You have to differentiate. It's sort of like chain rule, but it's not really. No, don't need this. You get d squared is equal to w squared plus l squared by Pythagoras. Alright. And then you just differentiate both sides with respect to time. So you get 2d dd on dt is equal to 2w dw on dt plus 2l dl on dt. Sub those in. At wl is equal to 912. D is equal to 15 by Pythagoras. And so 30 dd on dt is equal to 2 times 9 times 3 plus 2 times 12 times 2. dd on dt is it just works out to be like, I don't know, 2 times 9 times 3 plus 2 times 12 times 2 is 102. And divide that by 30, you get 3.4. 3.4 cm per second. That's your rate of change of your diagonal. Pro stuff. Find the points on the parabola that are the shortest distance from the point P10. This is another optimization question, I see. Alright, okay, so consider a point on the parabola. Consider a point like y naught squared. Consider a point t squared t on the parabola. Alright, on the parabola where t is a parameter. T is a parameter. So I'm parameterizing the parabola, but you really don't need to, I guess. Okay. Then you get the distance. Let the distance be s. Isn't s like what people usually use to represent distance nowadays? In like integration, I think. Alright, and then we just get, let the distance be s. S is equal to like, wait, no, s squared is equal to x minus 1 squared plus y squared, which is equal to t minus 1 squared. No, t squared minus 1 squared plus t squared. Are you sure? That seems That seems not right. Okay, now I'm pretty sure it's fine. Which is equal to t to the 4 minus 2t squared plus 1 plus t squared, which is just equal to t to the 4 minus t squared plus 1. Alright? So that's s squared. Now s is equal to the square root of that. And it's since we're going to use chain rule, it's just much more convenient to just write it with brackets. To the half. So ds on dt is equal to, so it's negative a half, right? You derivative what's outside the brackets. So you get half, and then it's to the power of negative a half, right? Right, yeah. And then t to the 4 minus t squared plus 1. And then you have to derive what's inside the brackets. So it's 4t cubed minus 2t. Something like that. Alright, yeah. And that is equal to 0 when? It is equal to 0 when... Okay, now note that, actually, which is equal to like 2t cubed minus t on root 4t to the 4 minus t squared plus 1. Note that t to the 4 minus t squared plus 1, the square root of that is equal to the square root of t squared minus 1 squared plus t squared, which is greater than 0 because sum of squares are non-negative, and we cannot get t squared minus 1 equals 0 and t equals 0 at the same time. Since ds dt is equal to 0 is equal to 2t cubed minus t on the square root of t to 4, that thing, then you just get 2t cubed minus t is equal to 0. 2t squared, no, 2t, t squared minus 1, no, t times 2t squared minus 1 is 0, t equals 0, or t is equal to 1 on root 2. Right. Okay. That looks promising. Let me grab a drink. Alright. So, do we really have to second derivative test? Like that just looks horrible to derive again. Isn't that the rule in scholarship where it says if you used a CAS calculator, that's allowed, but you have to like cite the command that you used. So I'm just gonna where's my CAS calculator? Alright. So I got my CAS calculator. And I'm just gonna say d squared is by CAS calculator d squared is on dt squared at t equals 1/2 1 on root 2 is equal to, actually I forgot how to use this thing, it's been so long. Actually, you don't even need the CAS calculator, right? The normal graphic calculator can do it. Alright. So, by the graphing calculator. By the graphing calculator. Option calc, which is if4, and you go d on dx of, no, you want d squared on dx squared, so that's if3 of the square root of x squared minus 1 squared plus x squared at x equals 0 is going to be -1. And then at 1 on root 2, I think those would be the minimum. Well, those would be the minimums. Far out. Low batteries. That seems kind of suboptimal. That seems very suboptimal. Alright, let me get a change of batteries. Alright, so the second derivative is at t is equal to 1 on root 2 is like 2.309, which is greater than 0. At -1 on root 2, it's probably just going to be the negative of that. Oh, no, wait, no, it is the same thing, yeah. Because it's also the, yeah, okay. So t is equal to 1 on root 2, -1 on root 2 are minimums, and t equals 0 is a local maximum, and as t goes to plus minus infinity, s goes to infinity as well. So t is equal to 1 on root 2, -1 on root 2 are absolute minimums. Right, there we go. And that should just work. And that is question 3 done. Space to split, right? Yeah, okay. Cool. Question 4. These are actually like non-trivial so far. It's pretty cool. For A, given two functions, use first principles to prove. Alright, so this is just this is just product rule, but proven from first principles, right? So it is just like you do the d on dx of if x gx is equal to lim as h goes to 0 of if x plus h g x plus h minus if of x g of x on h, right? That's from first principles. And then, which is like presumably just gonna be equal to some stuff. How do you do this? You have to split it up into two things, right? Because it's, in the end, you get f of x. But how do you... Well, I mean, in the limit, don't you get... Wait, I swear I've seen this before. They use like a square, right? They had like a square. And then it was like x, h, f of x, f of x plus h. Right, so, okay, so you're supposed to just factorize it. I think it's kind of dodgy to just draw the square. It's kind of dodgy to draw the square and just put it as your answer. So I'm just gonna try and do it properly, I guess. So basically the idea is that you have g of x here. G of x plus h minus g of x. The idea is that like g of x plus h minus g of x times by f of x plus h minus f of x all over h has to go to 0. That's the idea, I'm pretty sure. So well, if you just expand, if we just expand that, Alright, I got it. Okay, so the limit is equal to g of x times f of x plus h minus f of x plus, and that is equal to lim as h goes to 0 of g of x Alright, done with question 4a. Okay. It was just expanding stuff out after you figured out that after you figured out the square thing, you just expand a bunch of algebra and then you get it. Wait, Yichen, this is a New Zealand exam, right? So it's a lot of New Zealand people. Alright, 4BI. Okay, 4BI is just integration by parts, right? Crap. If g prime is equal to, so if prime g plus if g prime. Yeah, okay, so this is integration by parts. So what one do you set? It was like logarithm. I can't remember the mnemonic, but I think I'll try both ways. Well, the fact that they say the integral of f prime g dx, it kind of implies that you should look at the you should set f prime to be equal to e to the negative x and g to be equal to cos x. All right, let's see what we get if we do that. All right, all right. I think it should just work, but I'm not quite sure. Bruh, you get like the integral is equal to like negative e to the negative x cos x minus the integral of e to the negative x sin x dx. Which is like, then you still have to integrate like plus c, I guess. Then you still have to integrate e to the negative x sin x dx. Surely it just cancels. Alright, what if we let f be e to the negative x? Then you get f prime is still negative e to the negative x. But then if we let g prime be cos x, then we get g is equal to sin x, alright? So if we do it this way, it's if prime g, if g prime e to the negative x sin x minus, and you would be minusing like, it's minus if g prime, right? So it's minus e to the x sin x dx plus c. This seems highly sus. Oh wait, no, it's negative of that. So you get negative because if prime was right. Okay, I got it. Wait, there's a massive brain. Then you just add these two together, right? You just add these two together, and then you get like 2 times the integral of e to the x cos x dx is equal to negative e to the negative x sin x plus cos x. What the hell? This is actually massive brain. E to the negative x sin x plus cos x on 2. This is actually massive brain. Alright. Oh, plus c, of course, plus c. Alright, pro stuff. Find in exact form the area between the curve. Okay, so that is just, so we have the integral. Then we just want it between pi, it's between 0 and 2 pi, so that should be relatively easy. Sin x plus cos x on 2. Just evaluate that between 0 and 2 pi. And then what do you get? You get negative e negative 2 pi times sin x sin 2 pi plus cos 2 pi on 2 minus negative e negative 0 sin 0 plus cos 0 on 2. Alright? Which, and then the top is just like negative e negative 2 pi times a half, right? So it's on 2 plus 1 on 2. Alright. Done. And then for c, it's just y is equal to fx is defined implicitly by the following. Y is equal to fx is defined implicitly by the following. It would just be like, it's just implicit differentiation twice, right? So you get xy plus e to the y is equal to 2x plus 1. And then surely you can just like, alright, let's just differentiate with respect to x, whatever. So you just get y product rule, y plus x dx, the x dy on dx plus e to the y dy on dx is equal to 2. Alright? And then wait, do you literally just differentiate with respect to x again? But how do you differentiate? Wait, no, you go like crap, I forgot how you do this. You just differentiate. Crap. You just different. You have to. Um. How do you do this? Is it in the formula sheet? There's nothing in the formula sheet about this, right? Yeah. Wait, no, there is. Wait, it says D. Wait, hold up. Wait, no, this is parametric function. Okay, so it doesn't apply here. This is a bit sad. Alright, so this is a formula sheet. Um. I am going to skip this question and come back to it later when I remember how to implicitly take second derivatives. Alright. Question 5. Euler discovered a very useful formula shown below. Okay, so that's just like the normal. That's just like the normal that's literally just okay. That's just either I pi is equal to cis theta. Okay. Either I theta is equal to cis theta. Use the formula otherwise to show that. Alright, so if we just sub it in, right? 5a, e to the I theta is equal to cos theta plus I sine theta. But e to the negative I theta is actually equal to cos of negative theta plus I sine negative theta, which is actually equal to cos of theta because cos is odd, right? Cos theta is equal to cos of theta is equal to cos of negative theta. Negative sine theta is equal to sine negative theta because sine is odd, right? Okay, so then we just add those two together. You get e to the I theta plus e to the negative I theta is equal to 2 cos theta, and then so you get cos theta is equal to e to the I theta plus e to the negative I theta on 2. Right, pro stuff. Oh, that was only the first part. There's a second part. Okay. This is De Morvis formula, right? So you just go by De Morvis formula. Wait, no, you don't even need De Morvis formula, do you? Because you just go like e to the 3 theta is equal to e to the 3I theta is equal to cos of 3 theta plus I sine 3 theta, right? But then you also have e to the 3I theta is equal to e to the I theta cubed. Right, this is the massive brain. And then you go, which is equal to cos theta plus I sine theta cubed. This is, wait, this is like, this is just the Morvis. So, but it's phrased in terms of e to the I theta. Because that's what the question was set as. So you might as well. Just expand this. 3 cos theta, and then I squared is, wait, no. Plus 3 cos squared theta, I sine theta, minus 3 cos theta, I sine squared theta, because I squared negative 1, minus I sine cubed theta. Okay. Okay. And where do we... Oh, right, yeah, okay. And then equating imaginary parts. Equating imaginary parts. By the way, I'm on 5A part 2 now. I skipped 4C. I'll go back to that later. Equating imaginary parts, you get sine 3 theta is equal to 3 cos squared theta sine theta minus sine cubed theta, and then cos by Pythagorean identity. Oh, is there no like... Okay, never mind. It can be shown that... What? Wait, didn't we literally do this in like... Oh no, that was e to the negative x cos x dx. Okay. So this is different, I guess. Slightly different. Alright. Right, so this is like because cos from part AI cos x e to the x dx is equal to a half e to the x times e to the ix minus e plus e to the x times e to the negative ix dx by part AI. Does that work for like, does that formula work for negative I as well? Cause like, if it does, that would be pretty silly. This is kind of silly question though, not gonna lie. And 5D also looks pretty silly. But but okay. Bruh, how do you do this? It's like, can you literally just say it can be shown that that is true, right? But then is e to the negative ix times ex the integral of that is can it be shown? Can it be shown that the integral of that is um mm, this is highly unfortunate. Alright, I'm just gonna assume it's fine. It has to be, right? Because that's just how. Alright, pro stuff. I hope you weren't supposed to do something like massive brain for that, cause yeah. So Z is on the unit circle. So 5C, Z is on the unit circle. Z equals 1. So I plus Z is, so it goes 1 unit up. And I minus Z is you take I and you take Z. And it goes like 1 unit that way. Nah, you don't need to do this because you can just bash, right? You can just, this is like this, yeah, okay, so W let Z is equal to X plus IY. I plus x plus iy over x plus x. Wait, no. It's negative x minus I plus 1. Wait, no. It's I plus x plus iy over I minus x minus iy. And then if you just multiply by the conjugate, you should just get stuff. So you just negative ix minus y plus 1 minus x squared plus ixy minus ix minus ixy minus y squared plus y. Right. And all of this is over x squared plus y squared minus 2y plus 1. Now you can just see that the 1 and the x squared and the y squared cancel. The two y's cancel. The ixy cancels, but the ix's don't cancel for some reason. Alright, so you get negative 2ix on 2y plus 2. So which is ix on y plus 1. What's the locus of that? Alright, the locus question is so silly. Ix on y plus 1. That's what I get the locus as. But ix on y plus 1 isn't really. So it's like x on y plus 1, but they're rotated 90 degrees. X on y plus 1, but they're rotated 90 degrees. This still doesn't make sense. This locus question do be kind of making epsilon sense to me though. I'm gonna skip the locus question, I think. How many pieces of paper do I have? Not a lot. Okay. Okay, it's all good though. I don't understand. Let's try some random points. Alright, what if z is 0? Wait, no, 0 doesn't work. Okay. Let's try like 1i, -1, -I. So it's like I plus 1 on I minus 1 is equal to I plus 1 squared on 2. Whack. So that's like I plus 1 is like the 90 degrees one. Oh, so it's like the 135 degrees one. Okay. I'm not sure whether that actually is. This seems kind of random. Wait, actually, no. It's like I plus 1 squared is like the 90 degrees one. I plus 1 squared just becomes like becomes 2, right? And okay, so when z is 1, w is I. Okay. When z is I, w is undefined. Yes. When z is -1, w is 1 on I or -I. And when z is -I, w is just 0, right? Yep. Okay. That's not too bad. If rip. Oh, we're like 149 in. Okay, that's pretty suboptimal. Okay. I'm gonna leave 5C, I think. 5D. System of equations. Actually, I saw a pretty similar-ish problem the other day, where it was just like, it was like 3 variables, 3 equations, but it wasn't like, it was like cubic, I think. And so you basically you just like Oh, what do? You have to. Alright, let's try like the silliest thing. What if you just sum them all together? You multiply by 2 and sum them all together. 2x squared minus 2yz is equal to 2. 2y squared minus 2zx is equal to 4. 2z squared minus 2xy is equal to 3. No, 6. And then you get like x minus y squared plus y minus z squared plus z minus x squared is equal to 12. Okay. That's not really what we want. Because if that was gonna work, then it had to be 0. But, okay. Let's try and find one solution first. Fairly sure you should just be able to find one solution. Like, I don't know, x. Unfortunately, I don't think the graphing calculators can do it. If they can, though, that would be pretty pro. Do we think do I think the system of equations will have integer solutions? It might. So I don't know. Why don't you try like x equals 2, y equals 3, z equals 1. Does that work? No, it doesn't. X equals 2, y equals 1, z equals 3. That doesn't work either. Okay. Okay. This is like actually non-trivial. Alright, what if we made the substitution? X is equal to wait, I'm actually okay. I just figured out how to do 1b. It's not it's so stupid. It's not even it's nothing to do with trigs. It's nothing to do with trig functions. It's literally like what happens when you differentiate x to the 4 plus a to the 4 to the power of a half. Like what happens if you differentiate that? Because you get like, okay, so you get the half, right? And then you also get x to the 4 plus a to the 4 to the negative a half, right? And then you also get 4x cubed, right? Does this look for like this is literally okay, which is 2 times the thing that they gave us in the problem. Oh, that's so silly. Okay, but anyway, okay, and then so you get the integral of that. Oh, that's so silly. There's a half times x to the 4 plus a to the 4 from to the power of a half from a to 0, which is a half times. Alright. That was so silly. Okay. Well, at least I solved it now. So I guess there's that. So actually, I only need 4C, 5C, and 5D, and then I'll be done. Currently, I'm doing 5D, I guess. Why is this is actually non-trivial. So you get the sum of the squares of the differences has to add up to 12. But I'm not sure if that actually helps. Okay, what even kind of shape is x squared minus, it's these kind of stuff. It's like a hyperbola, but not quite. Alright, I wonder if we can solve this question numerically, at least. Like, if you fix x, then what do you get? You get like y squared is equal to 2 plus xz. Z squared is equal to 3 plus xy. Right? And then if you have these two, you can combine them somehow, maybe. Alright, you get something silly. You get like yz squared is equal to 2 plus xz multiplied by 3 plus xy. Maybe you could even sub that back into the first equation, and it gives you something. Or maybe you could just bash this. Like, it shouldn't be too bad, right? You only end up solving like a degree 8 equation or a degree 4 equation. I'm not so sure, but okay, what do you get? Because you get like, you can get y is equal to x squared minus 1 on z, right? Like, and then you sub that in, you get like x to the 4 minus 2x squared minus 1 plus 1 on z squared minus zx is equal to 2. Alright. Z squared minus x cubed minus x on z is equal to 3. Multiply through by z. Multiply the top one by z squared. You get x to the 4 minus 2x squared plus 1 minus z cubed x is equal to 2z squared. Okay. Oh, that's actually not too bad. That's not too bad. Because you get... And on the bottom, you multiply by z, you get z cubed. Get something super silly. Z cubed minus x cubed minus x is equal to 3z. That's what you get on the bottom. Multiply through by x. Xz cubed minus x to the 4 minus x squared is equal to 3z squared. And then you can actually just remove the x to the 4s by adding. We add those two equations together. You actually remove the x to the 4s. You remove the z cubed x's. And then what you're left with is something like negative 3x squared minus plus 1 is equal to 5z squared. And that is actually not too bad, but how do you solve it? Good question. Are there any of the equations where x is only like a degree 4? Because if not, then you just have to square it and it looks horrible. Um, 5z squared is equal to 1 minus 3x squared. I think this is correct. Wait, no, it's 2z squared plus 3z is equal to, yeah, okay. That's even worse, right? Because that's just silly. Or it might be big brain. What kind of polynomials can this thing numerically solve? It can solve polynomials up to degree 6. So as long as I get a degree 5 or 6 polynomial, as long as I don't get a degree 8 polynomial, I can numerically solve it with a calculator. Alright. So we sub it back into the top equation? No, we can sub it into the bottom equation, right? Wait, it's 3zx actually. Wait, this is a miss. So you get, okay, see, take the top equation. That cancels, that cancels, that cancels. This is kind of silly. Wait, can you just infer stuff right now? I swear you should just be able to like. Okay, it's 2 hours and 12. Okay. X squared minus YZ equals 1, Y squared minus ZX equals 2. Bruh. I just need one solution. Just want to find one solution. You just need to find one. Rip. I don't understand though. Okay, so you get Z cubed minus X cubed. Okay, minus X equals 3Z. But you know that. Okay, so you just take that. I reckon. I reckon you just take that and then you can go like Z cubed 2Z cubed minus 6Z is equal to X cubed minus X. Maybe there's some sort of substitution that works. Uh, Is there like just some random substitution? Because if these was linear rather than being quadratic, it would be like trivial. I don't think bounding. Also, NZQA seems to imply that there's only one solution. Alright, I'm fairly sure. Bruh, how do you take an implicit second derivative? Oh wait, this is so silly. dy dx. think. Hmm. I think it's dodgily solved for C. Hmm. Formula sheet have anything? But I swear 5C is probably wrong. I think. I'm just gonna do 5C again. for 4C, I got -8. Wait, I swear, I just realized 5C, I swear, it's like a Mobius transform, right? So it's like sort of like an inversion. Wait, 5C is like an inversion, right? But like a weird inversion. Mobius transform is like AZ plus B on CZ plus D, right? Where like A, B, C, D are complex numbers. So 5C is a Mobius transform, right? But then, so it should send circles to lines. So W, this is the locus of W should be a line, right? And then I know that if you plug in Z equals 1, so like this was like small cases that I did. If you plug in Z equals 1, you get W equals I. If you plug in Z equals I, you get W undefined. And then if you plug in Z equals -1, you get W equals -I. And if you plug in Z equals I, you get W equals 0. So since the locus of W is a line, then the locus of W is just straight up the Z axis, right? So this is big brain. Wait, but that implies Wait, is that actually correct? No, I'm doing 5C. That's the locus question. So it sends clerkles to clerkles, right? And then since this is so dumb. This is actually so dumb. Mm. Wait, I just realized I solved this whole time. Because I got it that it was W equals I times x over 1 minus y, right? But then where Z is equal to x plus IY, and then actually x and y are both real, so this is just all real numbers. So W is the x over 1 minus y is in R. So W is the y-axis, pretty much. Y-axis or imaginary axis. Wait, I'm so dumb. Imaginary axis. Okay. Sort of one. No, I don't think it is. It was like this kind of thing was like AMO 2019 question 2, I think, or 2020 question. No, it was like AMO 2020 question 4. Yeah, okay. Uh, I plus z over I minus z is a Mobius transform. It sends circles. Declines. Bruh, imagine. Alright. So, alright, time to easy dub question 5D. Do I still have paper? That's a good question. Alright. Alright, how do you solve 5D? 20 minutes on the clock. I swear you can just bash it by like subbing in. You just eliminate you just eliminate variables from the equations, right? Like you just go. Hmm. Alright, what's like a level 3 way to solve this problem? Because they can't, NZQA technically can't put in anything higher than level 3, right? So there must be some really dumb level 3 way to solve this problem. Where you just like apply some stuff. Like this is a, what's it called? Like 2y squared minus 2zx equals 4. Bro, so sum of squares is just stupid. It's not gonna work, I think. Well, yeah, AMGM fail, I mean. 5D is so cancer. Why is NZQA like this? Wait, I think I'm massive brain. Okay, what happens if you square the first equation, but then what happens if you square the first equation, but then multiply the other two equations together? Does that work? Because then you get yz squared and a whole bunch of stuff though. So no, that doesn't work. I'm just gonna try just elimination again. Because what do you get? You get like y is equal to x squared plus 1 on z, right? Where x squared minus 1 on z. Then if you sub that in, you get x to the 4 minus 2x squared plus 1 on z squared minus xz is equal to 2. And you also get z squared minus x squared minus 1 on z is equal to 3. Wait, this is literally what I got before, but no harm doing it again, I guess. Implies that this when you multiply by xz, and then you get because now I get 1 minus 3x squared is equal to 2z squared plus 3zx, right? And then surely you can just do something with that. 3zx is also like wait, you get something really silly. Because 3zx is equal to like what? 3zx is equal to 3y squared minus 6, right? So you get 3x squared plus 3y squared plus 2z squared equals 1. I feel like that's progress, but I also don't know how it's progress. It seems... Wait, no, it's equal to 7. Not... Yeah, so it's equal to... No, it's equal to -5? That makes no sense. No, yeah, it has to be equal to 7. This seems wrong. Unless some of them can be negative? Bruh. What do you mean time waster? Like, it's really bashy. I thought so, yeah. But I must be doing the algebra wrong. So this is so bad. Two z squared plus 3xz plus 3x squared equals 1. If you, I acquired some knowledge, by the way. If you subtract, you need to try subtracting equations or something. So I'm just subtracting like 1 from 2, right? Then you get like a bunch of cool stuff. Wait, so you get like y minus x is equal to 1 on x plus y plus z times y minus x is equal to 1. Y is equal to x plus 1 on x plus y plus z. Z is equal to x plus 2 on x plus y plus z. Right? And then you get like some dumb stuff, right? Because x plus y plus z is now equal to 3x plus 3 on x plus y plus z. X plus y plus z equals 3x plus 3 on x plus y plus z. Seems a bit dodgy. So, y so you get y is equal to x plus 1, 1 on x plus y plus z. You get z is equal to x plus 1 on x plus y plus z. No, that's equal to y plus 1 on x plus y plus z. So you get that x, y, and z are in like arithmetic progression. So it's like x, y, z are in arithmetic progression. So let x and the common difference is 1 on x plus y plus z. But I don't think you need that, cause you already get cause you already get you get two equations, right? Cause you get x squared minus x plus d, x plus 2d is equal to 1. But then you also get x plus d squared minus x plus 2dx is equal to 1. Right, so if you expand the top, bruh, you still get dumb quadratics. But I guess you can't really help it. Alright, so you get like, you cancel a bunch of stuff. So you get d squared equals 1, pro stuff. So you get 3dx is equal to 1 minus 2d squared, which is equal to negative 1. D is equal to plus or minus 1, so d equals plus or minus 1, right? And then you get like, and then you get like, and then you get like, so if d is equal to 1, then x is equal to 1 on 3, right? But that just doesn't, what? No. Oh, right, okay. So d is equal to negative 1. Then x is equal to negative 1 on 3. Then, no, that doesn't work either. Because isn't d equal to x plus y plus z? Alright, let me do all my algebra again. Rip. Okay. So we take the second equation minus the first equation, right? You get y squared minus zx plus yz minus x squared equals 1, which means y squared plus z times y minus x squared equals 1, and then thus you get, by difference of two squares as well, you get x plus y plus z, y minus x equals 1. Alright, and then you get x plus y, similarly you can get x plus y plus z, z minus x equals 1. So, which implies that, no, z minus y equals 1, which implies that they are in arithmetic progression. So say the common difference is d. then what you get is you get x squared minus x plus d x plus 2d is equal to 1, and you also which means x squared minus 3dx plus minus 2d squared is equal to 1. But also you get x plus d squared minus x plus 2d is equal to 2, which implies that x squared minus 2dx plus d squared minus x squared minus 2dx is equal to 2, and then you cancel the x squared, so you get d squared equals 2, which implies that d is equal to root 2 plus or minus root 2. But actually you get d is equal to d squared equal 2, and then on the other side you get 3d negative 3dx is equal to 5. X is equal to 5 on 3d. And then if d was root 2, then it would be x equals 5 on 3 root 2. And y equals 5 on 3 root 2 plus root 2. Is it equals 5 on 3 root 2 plus 2 root 2. And we can check if that works. I don't think it does. No, yeah, it doesn't. It's because x squared minus yz is negative 9 in that case. So we try negative root 2, and then it's also negative 9. So I'm not sure. I'm not sure what's supposed to happen here. So there's no solution, right? That means there's no solution. Wait, there's just no solution, right? That just means there's no solution. Cause, wait, the common difference is root 2 or negative root 2. But either one you try, the first equation always gives you negative 9 instead of 1. So there's no solution. What do you mean fake solving? I'm not fake solving anything. These are... Bruh. Wait, but they are in arithmetic progression, right? Wait. the common difference d squared is equal to 2. Oh, x is equal to negative 5 on 3d. Does that help? Oh, now it's correct. Pro stuff, pro stuff. Mr. Negative sign. Alright, and surely both of them work, right? Both negative 2 and 2? Okay. Alright, I got the solutions. Pro stuff, pro stuff. Alright. 3 minutes, 3 hours and 14 minutes is a bit suboptimal, but I guess. Alright, so Q5, alright, nice. 3:14:53.